All right, so 1.2, just a super brief explanation of everything that we've covered so far. So using objects, we use the turtle as an example. It's just objects in programming is just a virtual object like in real life. You can kind of think of it that way. There's a class diagram right here that has attributes that describe each object. The methods describe what an object can do right here. We're going through all of these, and right now we are on 1.2.5 calling non-void methods. That means something is going to be spit out of, a value can be spit out of a method, and you can use that value for other things. The enduring understanding for this entire section, sub-objects and concepts are so frequently represented that programmers can draw upon existing code that has already been tested, enabling them to write solutions more quickly and with greater degree of confidence. That's huge. That's programming right there. If you're going to be a programmer, that's what you're doing. CSP did not focus on this. I think there was one little section we did where we focused on like code that already exists and then doing something with it. First semester CSP, which I don't think anyone was in that class. Oh yeah, you were. And then so was, no, that person's not in my class. They're in my calc class. Either way, I tried to change it this year for CSP to make it where there was a lot of existing code and messing with it. But like when you were on it, we were just writing code from scratch mostly. When you were on it, other people, it wasn't like this class, which is fine because I need to teach the basics. And there are a lot of people that teach those intro programming classes that way as well. But in this class, there's going to be a lot of code that's already existing, like the turtle, and you have to use that code. You're going to be doing that in today's activity as well. You're going to still be accessing that turtle code. So hopefully you're getting more comfortable with it. But very rarely do you go to a job and be like, okay, here's a blank terminal, start coding. It's like, there's stuff that you're going to be thrown into a project that other people are working on, and you have to kind of get up to speed with what they're doing. And sometimes it takes like a month before you even like start doing anything because you're learning what everyone else is doing already. That's why retaining programmers is such a big deal, because as soon as you have to hire another person, now you're paying for another person's month of training. You know what I mean? And so that's obviously not beneficial for a company to do that. Okay, so 1.2.1 was explaining the relationship between a class and an object. You should all be able to do that now, okay? Classes are basically factories that create objects, right? Here's all the stuff that you have to know from 1.2.1. An object is a specific instance of a class. A class is a formal implementation or blueprint of the attributes and behaviors of an object. So the class basically controls what that object can do and information about that object. I'm going to skip over all these. 1.2.2, instantiation, which is just creating an object. You're creating an instance of a class. An instance of a class is an object. Lots of words. Learning objectives, identify using its signature the correct constructor being called. Okay, so you can have overloaded constructors, but based on the inputs, you should be able to tell which one was created. Essential knowledge, the signature consists of the name and the parameter list. Remember, the parameter list is the same as input. I keep saying input, I should say parameter. They're the same thing though, but I should use the words that AP uses more. It lists all the values that are passed and their variable names. A parameter, again, it's the value that's passed into a constructor. Constructors are said to be overloaded if there's multiple constructors with the same name, but different parameter lists or different signature, it says right here. Let's keep going here. 1.2.3, oh yeah, and the new keyword, that's how you create a new object. Make sure you know how to do that. Calling a void method. So call a non-static void method without parameters. We used Drew's code today. He had that something method that had no parameters in it. So you should be able to do that. Essential knowledge. Okay, a lot of this stuff we kind of already went over. I don't want to bore people, so I'm going to keep going. Dot notation, make sure you know it's the object dot method, which is like the noun dot verb. The noun being the object, the method being the action, the verb for it. Let's see here. 1.2.4, call non-static void methods with parameters. So it's the same thing we just did, only this time it's with parameters in there, inputs. Again, we did that as the warm-up, so hopefully that helped cement that concept a little bit more. Essential knowledge, the method signature for a method consists of the name and the ordered list of parameter types. You can overload methods. Again, we went over that in the warm-up. You can overload them if they have a different set of parameters, different list of parameters. And then now we are on the new stuff. 1.2.5, calling a non-void method. The thing that you should be able to do by the end of doing 1.2.5, you should be able to call a non-static, non-void method with or without parameters. So I kind of just lumped these two together. With and without parameters. Let's see here. Essential knowledge. Non-void methods return a value that is the same type as the return type in the signature. Okay, which is a little bit different than what we're used to because we just usually put void in there. But say you wanted a method to return an int. You want it to spit out an integer value. Instead of putting void there, you have to put int. If you want it to be a double, you have to put double there. If it's a string, you have to put string. So you have to actually tell the method base. You have to name the method in a way so it knows what it's returning. You do not have to do that in Python. So if you took CSP, if you could just say return whatever, and it's automatically going to do that. Okay, it's a little bit faster if you do tell it what to do. I think that's why Java. Part of the reason why Java is a little bit faster because you're telling the code what to expect. It doesn't have to be flexible like Python. But you do have to actually write that in when you write the signature for the method. Here's an example of what I'm talking about. So kind of went over all that stuff. So all right, so this one right here, it says. So it's public double get temp. Okay, if you notice get is a verb, so that's the method. It's properly named here. The double is what it's returning. And this is return current temp. Okay, and that would be a double value. But if you notice there's a double there, not void. Okay, so that's what it's returning. To use the return value when calling a method. Okay, so this is an example of actually using that return. So right here, it's going to return or spit out. I always just say spit out the current temp. If you notice with the printout, it says water.getTemp. So it's going to run get temp and then spit out whatever's there. If you try to do this on a void method, it would be an error. Okay, but now it's using that return keyword to spit something out of that method. I'm just realizing now that these curly braces, this is embarrassing. Sorry. All right, sorry about that. All right, so it says the variable data type must match the return data type, otherwise you get an error. So right here again, it says that it's returning a double, and then down here it's returning a double. If it was returning an int, it would throw an error. Go, whoa, you said it was returning an int, and now it's returning a double? I'm confused. Again, as I said before, like computers are the most literal people. They're not people, but like the most literal thing in the world. Like they only understand what's exactly told of them. There's no gray area. They're not going to go, oh, he wanted to return a double, but he returned an int. I'm just going to make him return an int. They don't think that way. They're very, very black and white. I shouldn't say very. They're just black and white, period. And that's basically all of 125. Okay. Now, again, that's just a sneak preview. You're not expected to understand everything I just said right now. Maybe understand a little bit of the terms. Maybe understand a little bit of what's going on with what you're going to be doing, but it's not going to really replace the activity itself. Well, for some of you, I'm sure it will, but like you're still going to be expected to do the activity. You have plenty of time in class to do that.